till yesterday that we have just gone through the different measures and some normal distribution and all stuff. Let me just go through some couple of questions. What are the three different percentages that we work with the normal distributions?
68, 95, 97.
68, 95, and 99.7. Okay, right, good. So what do you mean by Gaussian curve? What do you mean by Gaussian curve? When a mean is equal to median is equal to mode, then that curve is called as a bell curve or a Gaussian curve. Okay, which represents the normal distribution. Okay, right. Okay, fine. Let's get into the probability distributions. So what do you mean by probability? Probability is again a statistic, right or wrong? It is not the perfect criteria that you are going to pick out, but obviously when you're calculating a probability, it is a percentile estimation of, or the chances, okay, that we are making an event successful or a failure even. Okay, so let us see the probability concept here today, and also let us understand different types of random variables. Okay, so if you can take a look at this probability distributions. If we can take a look at this probability distributions, probability distribution is listing all the outcomes of an experiment and the probability associated with each outcome, right? For every successful event or for every failure event to be considered under this probability distribution, so that counting all together should become equal to 1, right or wrong? So, and also here I'm taking an example that I'm going to toss a coin 3 different times. Okay, when I'm tossing a coin 3 different times, I want you to observe the number of heads. Okay, and there are a different possibility of heads. Like whenever I toss a coin 3 times, there might not be any head. Okay, maybe one time one head. Okay, so something like this, we need to identify the probability distribution for the number of heads. Okay, so in this case, probability distribution, we are talking about the probability distribution, not about how much probability it is there for getting one head, how much probability it is there to get 2 heads, something like that. I'm not talking about that part. I'm talking about the probability distribution for the number of heads. Okay, the probability of having 0 heads, the probability of having 1 head, the probability of having 2 heads, the probability of having 3 heads. This is the max probability, and the minimum probability is probability of having 0 heads. So from 0, 1, 2, 3 till 3, we have to make a probability distribution. Okay, how the probability is distributed across different events, that is what we have to identify. The probability of number of heads, which is 0, every time you will get a tail, all 3 times. The probability of getting a 1 head is different times. First time you may get it, second time you may get it, third time you may get it, something like this. If you can take a look at this particular chart, it will show you the number of heads, okay, for each and every possible result. And how many iterations it is? 8 iterations. Okay. So how many number of heads, the probability of getting 0 heads, 1 by 8. Why? Because one time you will get no heads at all across across uh, three different chances or three different events that you are going to conduct. The probability of outcome of getting one head, three times you can get one head, 3 divided by 8. If you can calculate the probability, you will get different probability, which is 0.125, 0.375, 0.375, 0.125. And distributing these points on a scale, you will get the probability distribution of number of heads which are observed in the three different tosses of a coin. Every one of you understand this part, or do you have any question? Two main things that we need to understand from here. How do we identify number of combinations or number of times that we can understand for a particular event to get its success, or to understand the probability of a one particular event? And then number two, then we need to understand the probability distribution, different probabilities for different events together, all together. If you just make a graph, that is called the probability distribution. Are you all good? Or if you do have any questions, please raise the question right now. So here, this is very important, the characteristics of the probability distribution. Guys, there are three characteristics which we need to understand for a probability distribution. I'm coming from a very scratch for this probability. Okay, the probability of a one particular outcome should be in between 0 and 1. Both values are inclusive. Okay, and the outcomes are mutually exclusive events. Okay, outcomes are mutually, why? Because one time that whatever you are going to get a value should not be required to be same for the another time. Okay, the outcome would be definitely mutually exclusive events. You're not going to replacing the outcomes are mutually exclusive events. And now the list is exhaustive. Why? Because we have a lot of list. Each and every time that you are tossing a coin, every time you have to make one combination. Okay, so if you go on doing it, you will get a exhaustive list, means which is a longer list. And but at the end, the sum of all the probabilities of various events should be equal to 1. Okay, right? Here we have something called a random variables. Before I'm going to start the random variables, if you have any questions in the probability distribution, please let me know. If you are okay, then fine. Then we can go ahead with the random variables. So now, coming to the random variable, a quantity resulting from an experiment that by chance can assume different values. Yes, the random variable is the one variable which holds different values based upon the situation. Okay, so when you are tossing a coin three different times, the combination whatever that you are going to get is always changing, keep on. Okay, obviously this can hold a random variable. Okay, here we do have two types of random variables. One is discrete random variable and the one is continuous random variable. We know already what is discrete and what is continuous, right or wrong? Okay, discrete is the something resulting from counting something. Discrete is something that is a result of counting something, whereas continuous is something like a measurement. Okay, we need to keep that in mind. A discrete random variables examples: number of students in a class, a number of children. See, all these things would be based upon the count. How do you count the people? How do you count the each and every event? Number of cars entering a car wash in Nava. Number of home mortgages approved by the Federal Bank. All these things are different examples of the discrete. Can you please let me know any one example from your end for identifying the discrete random variable? Raju, Rajesh, please try to identify the discrete random variable by giving an example. Number of pens in a pack. Okay. Number of people in a village. Okay. Number of students in the class is there in the example presentation, right? Ashok, you're trying to repeat the same thing again. Give your own example. Number of customers entering the store. Number of passengers gonna buy the ticket for today. Number of voters in the constituency. Good, Ali. Something like this, okay? We have to come out of with a lot of stuff like this. And now coming to the measurements. Continuous random examples. Distance students travel to the class. The time takes to drive to work. Length of an afternoon nap. Length of time of a particular phone call. Okay, and all these things could be considered as the continuous random variables. Okay, just for our common sense, I have listed all these things. Otherwise, they are not at all required. Features already that we have seen this one. Now, coming to the main part, the mean of the probability distribution. Remember that this is very, very important. Identifying the mean of the probability distribution. Okay, guys, how do we understand the mean generally? Sum of all the values together divided by total number of values, right? Here, a little bit different. Okay, mean is equal to sum of values, x values, into probability of getting those values. Got it? Huh? So this will represent the central location of the probability distribution. So the mean of the probability distribution over here, mu is equal to sigma x into p of x. Okay. How do we evaluate this x into p of x? X represents the values, okay, or different events, whereas the probability p of x represents the probability of getting that such an event. Okay. Variance and standard deviation. We know what do we mean by variance. A squared deviation of the scores from the mean. So this is what happening here. X minus mu whole square into p of x. If you can observe, there is a relation between the formulas that when we are using this, right or wrong? Earlier, whatever that we have seen for the variance, we are identifying that footprints of those variance over here in the probability distribution of the variance. Okay, let us take a example and let us solve this example. John Ragsdale sells new cars for the Pelican Ford. John usually sells the largest number of the cars on Saturday. He has developed the following probability distribution for the number of cars he expects to sell on a particular Saturday. Okay, so now this is the chart which is showing the probability and number of cars sold. Please identify the mean, variance, and standard deviation. Okay, fast. Please do calculate fast and let me know the answers immediately. You have everything over here in your slide, the number of cards, so x values are there, p of x values are there. Please calculate and let me know the mean and variance first. What is the mean value first? We have to do these kind of calculations many more. That's why I just asked you to hold one notebook and the pen with you. Okay, someone is giving me the answer mean 2.1. Mean is equal to 2.1. I'm not sure like how many more of you people are going to give me the different answers or the same answers. Okay, I'm getting different answers actually. We will sort out. We will see what exactly the main answer is. Okay. Okay, every one of you first give me the answer for the mean, then we will calculate the variance. Okay. Okay. Okay, mean I got many answers. Now I want something variance. Do it fast. We know the formula of variance, sum of x minus mu whole square into p of x. We have the x values and we know the mean, and we know the p of x. So guys, here we have the mean of the probability distribution, which is 2.1. Why I'm revealing this answer? Without actual mean value, you can't go further to identify the variance value. Okay, so the mean value is 0 into 0 0.1, 0 0.2, 0 0.3, something like this. Okay, with the respect to x values. I don't know how you got the different types of values, guys. Please cross check your answers. Okay, you should get the mean value, which is 2.1. Narayana, you got the right answer. Raju, you have given the right answer. Both of you good. 1.4. Okay, 1.488 is one of the answers I got. Let me just verify. It is 1.29 is the variance. You can clearly observe that you have to differentiate something from the mean. Okay, from x, 0 minus 2.1, something like this, and you have to make a square of it, and then square into p of x of each and every value needs to be summed together. You will finally get 1.29 is an answer. Okay, and the standard deviation you can directly go ahead and identify. Okay, that is very easy. So now coming to the binomial probability distribution, so let me just tell you what is probability distributions. So generally whatever that we have identified is a general probability distribution. Okay, likewise we have many probability distribution based upon different conditions actually. Okay, Bernoulli probability distribution, binomial probability distribution, geometric probability distribution, hypergeometric probability distribution, Poisson distribution. Okay, if you ask me, sir, how many probability distributions of this kind are existing, there are innumerous. There are innumerous probability distributions. Various researchers came with a different scholar stick related to probability distributions, okay, with their own methodologies of identifying something. But for all of for all of these things, the main basis of the mean and variance and the standard deviation formulas are sum of x into p of x, sum of x minus mu whole square into p of x, okay, root of sum of x minus mu whole square into p of x for the mean, variance and standard deviation. This is going to be the basic for everything. Okay, of course I will show you definitely for now about the binomial distribution. Okay, why do we use the binomial distribution and all, but the formulas whatever that we are coming out with the binomial distribution is somewhere resolved and made just for the sake of binomial distribution. Understand? in order to easily identify the situation and the probability distributions. Okay, here we do have binomial distribution will be having only two possible outcomes. One is yes or no, something like success or failure. Okay, the two outcomes are exclusively mutually exclusive, and each trial is independent. We all know all this stuff, right or wrong? We all know everything of this one. Now, the binomial probability formula is something like this. Okay, NCX. Here, when it represents pi, pi is not something 3.14 that we have mathematically. This is something like a P. P represents probability of a success for each and every trial. Okay, this is a binomial probability formula, NCX P of x into 1 minus P of n minus x. Okay, one is representing the success and another one is representing the failure. Okay, maybe P power x may be representing for the success. Okay, 1 minus P should represent. Why? Because when the sum of total failures and successes should become equal to 1, right or wrong? Okay, and if you're going to consider something like that, if x is going to be the random variable or number of successes that we are talking about, okay, so combinations, different combinations. Okay, why? Because you are binomial means binominal. Bi represents multiple times. Nominal type of variable, we know that if it is holding different data or different values or variable. Let us understand how this formula was built. Remembering the formula won't give you anything. We have to understand how this formula has got its own existence. NCX represents the combination number of trials that you made, number of successes that you have done. 10 trials you made. Okay, 10 trials you made, you got one success, NC1, 10C1. Okay, something like that. These are number of combinations into, you have to see, when you wanted to identify the probability, you need to collate everything. Number of combinations, what is the probability of the success, into probability of failure. The probability of success is number of times that you got the success. P is equal to probability of a success in each trial, power, what is that? X represents number of successes you are holding. Okay, probability power number of successes into 1 minus P represents, what is this representing? Failures. Okay, total number, n number of trials minus, remove the successes. Rest of them are failures, right? I told you 10 iterations or 10 trials, one success represents 9 failures. 1 minus P whole to the power of 9. Everyone understood this formula or not? This is the binomial probability formula. Everyone understand? If you want me to repeat one more time, I will repeat. If you don't understand something, that you please highlight it so that I will re-explain. Okay, so don't consider pi here. Instead of considering pi, you consider it as a P. Okay, why? Because you may compare this pi as a 3.14. It is not the pi, it is P. P is the probability of success in each trial. Okay, let me just subdivide all these things into 3 different parts. Okay, very simple. Number 1 is combinations. You need to make the combinations every time. NCX. Okay, here pi 0.5. Who told you it is 0.5? I haven't given you any answers, right? The probability of success or failure. No. That is what I'm saying. The probability of success or failure depends upon the situation or the problem. I did not define any problem. If I take a coin, then the probability of success is and the probability of failure is same, which is 0.5 and 0.5. Did I tell you that it is all about the coin tossing a coin? No. If I'm going to take a dice, the probability will be different. Right or wrong? Narayana, right or wrong? Okay, so do not rely on that one. This is just a formula I'm talking about. First combinations, and n represents number of trials. Okay, C, X represents number of successes. Okay, next one is P power X. P power X represents, P represents the probability of a success. Okay, probability power, probability power number of successes, right? X represents number of successes. Next one is 1 minus P. Okay, 1 minus P whole power n minus X. We know what is n, right or wrong? Huh? N represents total number of trials. Okay, why? Because n 1 minus P represents the failures. Failures power number of failed trials. Okay, so how do you get the failed trials? You have to minus the number of successful trials. Okay, so n minus X. Hope you understood this one. Now you take a look at this example. There are 5 flights daily from Pittsburgh via US Airways into the Bradford, Pennsylvania regional airport. Suppose the probability that any flight arrives late, the probability of arriving a flight late is 0.20. What do you mean by that one? 20% is the probability, right or wrong? 20% is the probability. What is the probability that none of the flights are late today? Means you have to identify the P of X is equal to 0. Okay, when it is a P of X is equal to 0, we know how many trials it is made. 5 flights daily, means 5 iterations. 5C, out of 5 flights you are targeting to not to have at least one flight is equal to late, means 0 flights are late. FC 5C 0. What is the probability? It was already given 0.20. 0.20 for power 0. 1 minus 0.20 means 0.80, which is failure, means all flights are going to be late, for example. Okay, means failures. If you calculate all together, the probability of getting none of the flights coming late is 0.32, represents 33% average. Okay, approximately 33% of the chances that we do have getting flight and none of the flights arriving late is 32%, 33% chances. Okay, so we have a mean and variance, which is a direct formula. Okay, mu is equal to np, sigma square is equal to np into 1 minus p. If you ask me one question, sir, can't we use the mean and variance of the earlier formula? You can always use it. You can always use it, but this is very specific to the binomial distribution where you can calculate it very fast. Okay, if you can take a look at this one, for example, you can calculate this much fast to identify the mean and variance, whereas if you just wanted to identify with the sum of x into p of x, you have to take something like this, which is little bit cumbersome. Hence you do have your own formulas for each and every probability distribution to make it little bit ease. Okay, all these things have been already researched and developed by the earlier mathematicians, so we have to just make use of them. Okay, and we need to create the models, that's it. Okay, So this is a binomial distribution table. Not only that, you can calculate by looking at the binomial distribution table based upon the probability that you got and the x values, you can always identify the number of trials based upon the number of probability trials and all stuff. You can identify the probability binomial distribution probability. Okay, the probability of getting the flights, 0 flights late. Okay, where this represents the probability here. Okay, and this represents the x total number of successes. Okay, if you are going to tally these two things, you always can get some sort of values over here, but it is always suggested not to follow this. Okay, go ahead with your own calculation rather relying on some other tables. Okay, so this is a cumulative version. Probability of getting number of successes. Okay, if you take a cumulative table something like this, when you are taking more number of trials, you can understand the way that you are getting the distribution. Where did you get the normal distribution? Here it is almost you got the normal distribution. This is how this is looking like. Right skewed or the left skewed?
Right.
Left skewed. This represents the right skewed. Okay, this is also right skewed. This is also right skewed. Okay, how this is changing? This is changing based upon the probability, and you are making that probability as a distribution. Okay, now you understood how we are using these shapes, how we can understand these shapes. Okay, so these are all for different trials. N is equal to for varying different trials and all stuff. Before I'm going to before I'm going to show you something related to the cumulative binomial probability distribution. Okay, we will look after the how do we do this one same thing in Excel sheet at least tomorrow. Okay, and then we will jump on to this cumulative binomial probability distribution. Okay, that will be better for us. Okay, and to understand some practical stuff based upon the problem, how do we do it with the Excel sheet? Got it, every one of you? Okay, so do you have any questions in the today's session, guys? Thank you, bye.